Hello everyone. Last class we talked about integrals to infinity, and there was one problem a lot of people had questions on from the homework, so I thought we'd go over it first. And it was going from 0 to infinity, and it was this function. So if we look at the integrals for infinity, we had 3 cases. And this one is the only one that doesn't have negative infinity. And we're going 0 to infinity, so our a would be 0. So we would rewrite it as the limit as t goes to infinity, 0 to t of our function. So we'll start with that. Well, the next thing we want to do is try and simplify this. And inverse tangents, you want to think about those. We could use substitution, because if we had the arctangent of the tangent of theta, we would just get theta. So it would help simplify this. So we want to start off with substitution. So x will be the tangent of theta. And then we take the derivative. We have dx equals, what's the derivative for tangent? Secant squared. So then we plug in. The limit as t goes to infinity from 0 to t. X will become the tangent of theta. Arctangent, tangent theta, all over 1 plus tangent theta. And the tangent is squared, so 1 plus tangent squared theta, because x is squared, quantity squared. And then dx is secant squared theta d theta. Now we need to simplify. Well, we know this will be theta. The thing you have to remember, though, arctan has a special range. If you remember from before, arctangent's range is negative pi over 2 to pi over 2. So theta has to be between negative pi over 2 and pi over 2. Which means then we can rewrite this for theta, and it will just go from 0 to pi over 2. Because it has to stay in that value, and we want greater than 0, so it's 0 to pi over 2. Then we have the tangent of theta times theta and our secant squared all over 1 plus tangent squared theta squared. We'll simplify some more. Can we get rid of 1 tangent squared? Yeah, 1 plus tangent squared, you should remember, it's your Pythagorean identity. 1 plus tangent squared is secant squared. So we can rewrite that. I'm going to move this theta in front. So then this can cancel with 2 of the secants. That'll be secant to the 4th, so it'll become secant squared. So we have theta, tangent of theta over secant squared theta from 0 to pi over 2. Now we can rewrite our tangents, and our secant is sine and cosines, so we can simplify them. Tangent is sine over cosine, and secant we know is 1 over cosine squared. When you're dividing by a fraction, you can flip it and multiply. And this will cancel with one of those. Does this remind you of anything? Cosine theta, sine theta? It should make you think of a double angle. This one here, sine theta, cosine theta. The only thing, oops, is that we have the 2 there. So divide by it. So then it's sine of 2 theta over 2. I'm going to pull that 1/2 out. And then we can use integration by parts. If you remember the formula for integration by parts, it looks like this. So you have to decide your u and your dv. You want the u to be something that breaks down easily. So u would be theta, because then du is d theta. It breaks it down. The rest of it then is dv. When you take the integral, dv is v, and the integral of the sine is negative cosine 2 theta over 2. We have our 1/2 out front. And then we multiply, we have theta times this, so we have a negative theta cosine 2 theta over 2 minus the integral of these two, negative cosine 2 theta over 2 d theta. Now we need to take our integral. I'm going to pull the halves out and make it 1/4. Negative theta cosine 2 theta. Negative and a negative is a positive. We pulled these 2's out. The integral for cosine is sine over 2. And we're going from 0 to pi over 2. Now we want to plug in our pi over 2. So we have 1/4 plugging in the top, negative pi over 2 cosine, and when we plug in pi over 2 times 2, we get pi. And then plugging into the second one, we have the sine. 2 times pi over 2 is pi. Minus plugging in the 0 would be 0. Keep putting sine. Plus the sine of 0. Because 2 times 0 is just 0. This one, we have 1/4 negative pi over 2 times the cosine of pi is a negative 1. And then this one is sine of pi is 0. This is 0. And the sine of 0 is 0. Multiplying these together, we have pi over 8. And so we get our answer is pi over 8.